Alright, so this video is going to be about percent yield, and so this is going to be a follow-up to the stoichiometry video that you previously watched. Anyhow, so the first question that we have to ask is, what is percent yield? So that's what we're going to do now, is we're going to get the definition and what it is out of the way. So uh, percent yield, you can follow me here. Percent yield is actual divided by theoretical. So when we go back to our stoichiometrical calculations, we're calculating the theoretical value of what that reaction might produce. So for percent yield, we're trying to figure out how much percentage is actually being produced from the reaction compared to what should have been produced. And so it's always going to be actual divided by theoretical multiplied by 100 to get you that percentage. So now we're going to look at two examples. One example you can see here, it's where a student completes the reaction above and determines that he produced only 300 grams of titanium from 400 grams of magnesium. What would his percent yield be? Now, I would expect, just from out of experience, that a student would take this number and they would say 300 grams of magnesium divided by 400 grams of titanium times 100, and that's going to give you 75% yield. Now, here's the problem. Are the units of grams of magnesium going to cancel with the grams of titanium? The answer is no. So that part can't be used. The question is, how do we determine the amount of titanium that's supposed to be produced from the 400 grams of magnesium? Well, we have to go back to the stoichiometry. And so what we're going to do is we're going to take the mass of magnesium and we're going to convert that into mass of titanium using those road maps. Now, again, this process will be a little bit more involved than the previous one, but let's just break down the road map. So we're going to take the grams of magnesium and we're going to convert that into moles of magnesium. Then we're going to convert moles of magnesium into moles of titanium. And then finally, we're going to convert our moles of titanium into grams of titanium. Now, so this is a 3-step problem. So the first step is we're going to take the 400 grams of magnesium and we're going to convert that into moles. Now, the roadmap tells us that we're going to divide by the molar mass of magnesium, which is 24 grams per mole. So that's the first thing we're going to do, is put in the 24 grams per mole of magnesium. Second step there tells us that we want to convert moles of titanium moles of magnesium into moles of titanium. All right, mole ratio again is going to be 1 mole of titanium per 2 moles of magnesium. All right, we get that from the balanced equation there. So we're going to have 1 mole of titanium on top and then 2 moles of magnesium on the bottom. And the final step is to convert your moles of titanium into grams of titanium. Now the molar mass of titanium again is 48 grams per mole. And let's just do a little unit dimension analysis here. So the moles of titanium cancel out, moles of Mg cancels out, and the grams of Mg cancel out, and we're left over with grams of titanium. Now, let's go ahead and do the calculation here. So you can take 400 divided by 24, divide by 2, and then times 48. What do you get? 400 grams is what you should get. Now, it doesn't always happen like this. Let's see if I get back up here. There we go. All right, so this is the amount that we should produce. So this is going to be your theoretical yield. Now, we saw earlier up at the top here that we're going to have, it's going to produce 300 grams of titanium. So that's your actual yield. This is your theoretical yield. So to calculate the percent yield, we're going to have 300 grams of titanium divided by 400 grams of titanium times 100, which is going to be equal to, now go to 3 sig figs on your calculator, so we get 75.0%. Yes, I know that what we calculated initially is what we just calculated, but we have to understand the units did not cancel out to begin with. So we have to pay attention to those units always. So in this case, the grams of titanium cancels out and you're left with no units in the percent. So that's one example of how to calculate the percent yield. We're going to look at a second example here, all right, which is I've already written up. So in this example, we're going to start with ammonia decomposes into nitrogen gas and hydrogen gas. We're going to write the equation and then we're going to balance it. So we're going to do that first. All right, so we're going to have NH3 yields, all right, nitrogen gas is N2 plus H2. So we see that there's 2 nitrogens on the right side, there's 1 on the left. So let's put a 2 in front of NH3. That gives you 2 nitrogens, and it also gives you 6 hydrogens, so we're going to put a 3 in front of the H2. Alright, so that equation is now balanced. And don't forget the physical states. They're all gases here. Alright, now the second step says if 200 grams of ammonia are decomposed, what mass of hydrogen gas will be produced? Well, here we're taking 200 grams of ammonia, and we want to figure out how many grams of hydrogen gas is going to be produced. We're going to have to do some stoichiometry here. So we're going to take 200 grams of NH3, and we're going to convert that into moles. So it's always going to be, so you're always going to convert your grams into moles. And then moles will get converted back into moles of hydrogen, and then finally moles into grams. So those are the basic steps that you're going to use in the calculation. So the molar mass of NH3 is 17 grams per mole, so we're going to divide by 17 grams per mole. And then we're going to take the mole ratio. Now we're looking for hydrogen to NH3, so that's 3 moles of hydrogen to 2 moles of NH3. Alright. And then this final step is to convert into grams. So you're using the molar mass. Molar mass of hydrogen is 2 grams per mole. Alright, so the moles cancels out here, these moles cancel here, and then this gram cancels here. Alright, so 200 divided by 17 times 3 divided by 2 times 2 is going to equal out to be 35.3 grams of hydrogen. So we move on to the next question. It says, if 12 grams of hydrogen gas were produced, what is the percent yield for the experiment? Alright, so we just calculated 35.3 grams of hydrogen. So remember, this is your theoretical. Alright, so we want to figure out the percent yield. So it's, again, it's actual divided by theoretical. So your actual yield was 12.0 grams divided by 35.3 grams, multiplied by 100. So that's going to be equal to 34.0% yield. So that's the answer to that question. Alright, so in the next video we are going to cover limb reagents, but for this one where we are trying to solve for percent yield, if you have any questions, just make sure you ask or put a comment below. Thanks.